All right, good evening and welcome to Master Talker online class. In today's video, we'll be solving some questions on AC circuit. All right, AC circuit. So the first question we're going to solve is let's say a capacitor of capacitance 4 mu farad was used in a radio circuit connected to a 50 Hz AC source. They say calculate the reactance. Okay, calculate the reactance. This is very simple solution. Now the reactance is given by XC, and which is what? 1 over omega C. And what is omega? 2 pi f. So this is written as what? 1 over 2 pi fc. So they gave me the f. My f is equal to 50 Hz. Okay, and they gave me the frequency. So they gave me the capacitor, which is equal to what? 4 mu farad, which is what? 4 times 10 raised power minus 6 farad. So my xc they are asking me is now 1 over 2 times 22 over 7 times my f is 50 times what? 4 times 10 raised power minus 6. So if you do everything, this 7 can go up. If the 7 go up, I'm going to have 7 over 2 times 22 times 50 times 4 times 10 raised power minus 6. Okay, so if you do everything there, you will be getting 7.96 times 10 raised to power 2 ohms. All right, so that is that, and very simple to calculate. The next question. So the next question says calculate the inductance of an inductor whose reactance is 1 ohm at 50 Hz. All right, so what do we have now for solution? I didn't give you that formula in the former video, so this is the second video anyways. So we have that x is equal to what? 2 pi omega L. The capacitor is 1 over, but in inductor there is no 1 over. So this is same as what? 2 pi f, then your L. So what do I have? 2 times 22 over 7 times what? My f is 50. They gave me this one as 1. So then times my L I'm looking for. So if I cross multiply, I'm going to have that what? My L is equal to 7 will go here. So 7 divided by 2 times 22 times 50. So if you divide that, you'll be having 3.18 times 10 raised power minus 3 Henry. So don't forget that your inductor is measured in Henry. All right, your inductor is measured in Henry. So that is that. The next question. So question number 3 said the resistance of a series RC circuit. So RC circuit means it contains resistor and capacitor. All right, RC circuit is 5 ohms. that is the resistance, okay, is 5 ohms, comma. Then they say if the impedance, if the impedance, if the impedance of the circuit is 13 ohms, then I say, comma, calculate the calculate the reactance of the capacitor. Okay, we should calculate the reactance of the capacitor. We will tell them that what, that since it contains R and C, so solution, our impedance Z squared is equal to what, R squared plus what, XC squared. All right, where XC is what, your reactance of the capacitor. So my impedance Z is your impedance, which is 13 ohms. All right, then your R, the resistor or the resistance, is given by 5 ohms. Okay, so now my XC is now unknown. So if you put it here, I have 13 squared is equal to what, 5 squared plus XC squared. So you have 169 is equal to 25 plus XC squared. So collect like terms, 169 minus 25 is equal to your XC squared. So this minus this will give you 144 is equal to XC squared. So my XC will now be the square root of 144, which is what, 12 ohms. Okay, 12 ohms. Very, very simple to calculate. So the next question, the next question said a series of the same RC again, that is resistor and capacitor circuit, okay, consisting of a 30 ohms resistor and a capacitance of reactance 40 ohms, okay, is connected across an AC source 200 V RMS 50 Hz. Okay, then they now say find the current that passes, find the current, okay, find the current passing through the circuit. Okay, now this is a very simple question. First of all, we need to get what they gave us. The first thing they gave us is the resistor. They gave us the R as my resistor, which is 30 ohms. All right, now they gave me the reactance of the capacitor, that is the capacitance of the reactance, which means reactance of the capacitor, which is what, XC, as what, my 40 ohms. So I need to get my impedance immediately. My impedance Z squared is equal to what, your R squared plus your XC squared. So I have that my Z squared is equal to what, 30 squared plus what, 40 squared. So my Z squared is equal to 900 plus 1600. So therefore my Z squared is equal to what, 2500. So my Z will now be the square root of 2500, which is equal to what, 50 ohms. Okay, since I've gotten my impedance as 50 ohms, now the next thing they gave me is 20 V RMS. Okay, so the volt there, the volt, that is the volt of the source, is 20. So they gave me that the voltage is equal to what, 200 volts. Okay, and the frequency they gave me there is 50 hertz. Okay, if they gave me frequency of 50 hertz, so what do we need to do? They say I should calculate the current. Current is given by Z is equal to IT. Please don't forget, Z is equal to IT, but there is no time there. So you should know that current current I, V is equal to IR. Don't forget, V is equal to IR. Very important thing to note. So, but we are not using resistor here. We are using the what? The resultant of all the resistors. And the resultant of all the resistors is now what? Your impedance. So I'm going to change this arrow now because I don't have one resistor here. I have two resistors. And the resistor is the normal resistor and the resistance of the capacitor. So what I'm going to use is their resultant. So instead of using V is equal to IR, I'm going to use that V is equal to what? IZ. All right. So I'm looking for my I. My I will now be what? V over what? Z, which is what? 200 divided by 50, which will give you this into this 4. That is 4 ampere. All right. 4 ampere. Very, very simple. Okay. We don't need that frequency there. We don't need the frequency for anything. Okay. So the next question. Right. The next question here said a coil of impedance, sorry, inductance. Okay, a coil of inductance 0.12 Henry, okay, and resistance of 4 ohms, okay, is connected across a 240 volt, 50 hertz supply, then I say calculate the current through it. Calculate the current through it. Okay. Now, if you look at this particular one now, you will see that this circuit has an inductor, a resistor, and a capacitor. So we have 3 things there. So you have to be very, very careful. So we need to get the resultant, what's it called? Resistor. Okay, that is the impedance. We need the impedance. Very, very important. So before the impedance, we know that XC for C capacitor is 1 over. So it's 1 over what? 2 pi FC. All right, which is what? 1 over 2 times 3.142. Let me use this one. Times my F is 50 times my C capacitor. Capacitor is measured in there is no capacitor here because capacitor is measured in what is it called? Capacitor is measured in farad, so there's no capacitor here. So this thing is this circuit only have a resistor and an inductor. So we have that what? X for C for L. Okay, there is no 1 over in this one. It's just 2 pi FL, which is what? 2 times 3.142 times my L here is what? 0.12 Henry. So if you multiply everything, you're going to have I don't have my calculator here. I'm going to have that this is 37.68 ohms. Okay, 37.68 ohms. So sorry, what of my F? My F first times 50, then times my 0.12. Okay, so that is 2 pi F and L. Okay, so now I need my impedance because they gave me the resistor as what? 4 ohms. So my impedance Z is equal to what? The square root, do it straight. The square root of R squared plus your what? Plus your XC squared, which is what? The square root of 4 squared plus 37.68 all squared. So what do we have now? If you do everything here, you'll be having that your impedance is where your impedance gave me 240. Okay, so the impedance here gave me 37.89 ohms. Okay, 37.89 ohms. So we'll now remind them that V is equal to IR. V is equal to IR, okay? V is equal to IR. Very important formula. But we are not using R here. We're going to use the resultant of the resistors, which is the impedance. So V is equal to what? IZ. So I'm looking for my I, which is what? V over Z, which is what? What is my V? 240 volts. So 240 divided by 37.89. So which will give you 6.33 ampere. 6.33 ampere. Okay? So that is that. Very, very simple to calculate. We keep moving. So the next question the next question said that an RLC, so it has a resistor, inductor, and a capacitor series circuit. Okay, consists of a 100 ohms resistor, 0.05 Henry inductor, and a 25 farad capacitor. Okay, then I say a 220 volts, 50 hertz means voltage is applied. Okay, so what happened after the application is applied across the circuit. Then I say calculate I impedance. Then I calculate the current. Okay, so this is a very simple question solution. Even without being told that we should calculate the impedance, we are supposed to know that we are to calculate the impedance. They gave me that my R is equal to 100 ohms. Okay, and they gave me that my L is equal to 0.05 Henry. Okay, and they equally gave me that my capacitor is what? 25 farad. So to get my XL is equal to what? 2 pi FL, which is what? 2 times 3.142 times 50, your frequency, then times your L, 0.05. So which will give me what? If I do that, my XL, where is my XL? Okay, my XL will now give me 15.7 ohms. Okay, so the next thing I need to calculate is my XC. My XC is 1 over, don't forget, 1 over 2 pi FC, which is what? 1 over 2 times 3.142 times my F is 50 times my C is in farad. So it is going to be 25 times 10 raised to power minus 6 farad. Okay, so it must be in farad and not in farad. So this is 25 times 10 raised to power minus 6 farad. Okay, so if you now punch everything in calculator, 1 over everything here, you will have that my XC is 127.4 ohms. Okay, so that is that. So I will now tell them that my impedance Z is equal to the square root of, don't forget that inductor must come before capacitor. It is now what? XL minus XC all squared. Then resistor is always staying on its own. That's the patapata of them all. It's always staying on its own. So I have that my Z is equal to the square root of 15.7 minus 127.4 all squared plus 100 squared. So if you do everything in that bracket, you'll be having 149.9 ohms. Okay, that is approximately 150 ohms. So I will tell them that what? I've gotten my impedance. So for I'll tell them that what? V is equal to IR. But I'm not using R here. Don't forget, the R I'm using is the what? the resultant resistor, which is what? Your impedance. So your V is equal to what? IZ. So if I'm looking for I, it will now be V over Z, which is what? The voltage they gave me there is how many volts? 220 volts. 220 volts, okay? 220 volts divided by my impedance, 149.9. So if you divide them, you'll be having 1.47 ampere. Very, very simple question to answer. Okay? So you see, AC circuit is the simplest topic in physics. Okay? So the next one, the next question. So the next question said a 40 farad capacitor, in series with a 40 ohms resistor is connected to a 100 volts, 50 hertz AC supply. Then I said, I draw a circuit diagram of the arrangement. Then I calculate impedance. I calculate current. I calculate the potential difference. Across the capacitor. So first of all, the first thing they want us to do is to draw it. So drawing it, the first thing they mention is what? The resistor. So you draw your resistor. Resistor is always like this, and you name it 40 ohms. 40 ohms resistor is connected with what? A capacitor. Is it a capacitor? Yes. It's connected with a capacitor of 40 farad. So capacitor is always like this, equal. Don't forget that they must be equal. Okay? So that's all. The next thing they connected it to is what? What else did they connect it to? 100 volts. So you put your volts and name it 100 volts. Then you close and tell them that what? A current is passing through it here. Okay? So that is that. This is your resistor, your capacitor, and your voltage. Okay? Then you can, by the side here, put your 50 hertz, the frequency there, your 50 hertz. So the next thing they say we should calculate is what? The impedance. Calculating the impedance is not a problem. So what do? You should tell them that they gave us C. They gave us C as what? 40 farad, which is what? 40 times 10 raised to power minus 6 farad. So, but I know that XC is equal to 1 over. For capacitor, it must be 1 over 2 pi FC, which is what? 1 over 2 times 3.142 times my F is 50 hertz times my C is 40 times 10 raised to power minus 6. So if you do that, you'll be getting your XC as you'll be getting your XC as 79.5 ohms. Okay, did they give us another thing? No. So my impedance Z will now be just the square root of XC squared plus R squared. R is always oga patapata of them all. Yes, he is their boss. So I will be having what? The square root of what? 79.5 all squared plus the resistor they gave me is 40 ohms. 40 squared. So if you do that, you'll be getting that your impedance is 89 ohms. 89 ohms. Okay, and I know it's approximately 89 ohms. Okay, so the next thing they say we should calculate is your current, and don't forget that what V is equal to IR, but I'm not using the R here. I'm using the impedance. So V is equal to what? IZ. So my I will now be what? V over Z, which is what? The voltage they gave me there is 100 volts. So 100 volts divided by my impedance 89. So if you do that, you are going to get 1.12 ampere. All right, 1.12 ampere. So the next thing they ask us to calculate is what? The potential difference across the capacitor. So permit me to clean here. Okay, the potential difference across the capacitor. I know that V is equal to IR. Okay, but the arrow I'm going to use here is no longer arrow, but what? The arrow for the capacitor, that is the the what's it called? Oh, the blah blah blah, that is XC. I've forgotten the name. This X is measured in ohms, so it's a resistor. So I'm going to use the what? V for capacitor is what? IXC for capacitor, which is what? 1.12 times XC is what? 97.5 or 79.5, sorry, 79.5. So if you multiply that, you are going to be getting 89 volts approximately. 89 volts. So you see, this is very, very simple to calculate. Very, very simple to calculate. So the next question here, right? So the next question here said an AC source of 220 volts of 220 volts and frequency 50 hertz is connected to a series arrangement of a resistor, comma, an inductor and a capacitor okay. Then I said if a current of 15 ampere passes through the capacitor and the potential difference across the resistor is 120 volts and that of the inductor is 50 volts. Number one, they say draw the circuit. Okay, I. They say calculate the potential difference across the capacitor. Calculate the potential difference across the capacitor. All right. Solution. Now, to draw the circuit, the first thing I have is let me draw it. Drawing it, let me say I have a resistor, and the resistor I have is which one is in ohms? This is my resistor. Oh, they did not give me the resistor. Okay. The next thing I have is what? My inductor. The next thing I have is what? My capacitor. And they are all connected to voltage, having current passing through them. Okay. But something happened. If you trace to this point, I have voltage that is passing through it. Okay, this is my V, this is my R, my L, and my C. Okay, up to this point, I have another one, and I have another one. So the potential difference across the resistor is 120. Potential difference across the resistor is 120. So I have 120 volts here. Potential difference across the inductor is 50. I don't know the potential difference across the capacitor. All right. Okay. So what do we do now? We know a formula that said now, but do we know the total voltage that passes there? Yes, we know the total voltage. The total voltage that passes there is 220 volts. All right. Then you now tell them that what? That your V, the total voltage, the resultant voltage is equal to what? The square root of, don't forget that inductor must come first. The square root of what? V inductor minus V capacitor all squared. Okay. Then plus V resistor. Okay. So this is the three of them. Okay, or these are the three of them. That's the correct statement. So what do we do? Or let me take this one here. Let me take this one squared here. It's the same thing. So let me get it. So the total or the resultant voltage that passes through everything is 220. So I have 220 squared is equal to what? My VL squared. The one that passes through this is 50. So I have 50 squared minus VC squared that I'm looking for. Then plus my VR I have is 120 squared. So this one coming here, I'll have 220 squared minus what? Minus 120 squared is equal to 50 squared. Sorry, not squared here. Their squared is outside here. So it's equal to 50 minus VC all squared. So if you do these two, you'll be having if you do these two, you'll be having 3 4 3 4 34000 is equal to what? 50 minus VC all squared. So 50 minus VC is equal to the square root of 34000. So 50 minus VC is equal to what? Is equal to what? 18.4. Okay. So now this one coming here, this one going here. Is it? The problem? Is it the capacitor that comes first or the inductor? Okay, sorry. For voltage, the capacitor comes before the inductor. So C here and L here. So you got to swap it. So I have 50. Sorry, I have my VC minus 50. So I have my VC minus 50. Okay, I have my VC minus 50. So I have my VC minus 50. So I have my VC minus 50. So this one can move here. So my VC will now be 184.4 plus 50. So my VC will now be, do that, I have 234.4 voltage. Okay. So that is that for that. So the next question, I think we move to power. Let's move to power. We have solved so many for this one. So let's move straight to the power. The power that are stored in a capacitor. Sorry, in an AC circuit. All right. All right. Okay. So let me see my time. Oh, okay. So I think I'm going to stop here. In the next video, we'll now solve questions involving the power in an AC circuit. All right. Okay. So that is that for that. But let me just answer just one question here. There is a question I saw here. Okay, that should be your assignment. So this is your assignment. Then you tell me the answer on the comment section. So I have this, and I wrote it 0.5 Henry. Okay, moving like this. I now have something like this. I call it 4 mu farad. Moving like this. I have another one that is like this that I called 12 ohms. moving like this. I now have another one that is circle that I did like this, that I called 220 volts and 50 hertz. Okay. So they now said calculate the what? The resonance frequency. Calculate the resonance frequency. They say calculate the resonance frequency. The resonance frequency is given by 1 over 2 pi the square root. Please, the resonance frequency is given by F0, which is what? 1 over 2 pi square root of what? LC. Please, this formula is another important formula. Okay? The square root of this, the resonance frequency. Or, let's see if we can get the answer by calculating the resonance frequency. Okay, this is the formula for the resonance frequency anyways. So but can we get it by impedance? Yes, we can get it by impedance. The resonance frequency is the frequency of the impedance. That is the resonance frequency. Okay, so you can decide to calculate the impedance. Then from the impedance you now get the resonance frequency. So if you cannot remember this formula, first of all get your impedance, and then you now know that impedance is your impedance is the same thing as where is it? Okay, so how do we get that? Just say that your XL is equal to your XC. That's how to calculate the resonance frequency. So XL is always given by 2 pi FL is equal to, for this one is 1 over 2 pi FC. All right, so from here we have, you can cross multiply and then you get your resonance frequency. So if you cross multiply here, you will now have that. Cross multiply this time, this will give you that that your 2 pi all squared. Okay, I have my F squared LC, okay, is equal to 1. So my F squared is equal to 1 over 2 pi all squared, then FC, sorry, my LC. So you see that the F I'm looking for is now the square root of everything, 1 over 2 pi. So if you now get it, you will now get this formula. So if you cannot remember the formula, just say that your XL is equal to XC, then you now get your F. Don't put this particular F here. So that is that. So tell me what you get as the answer at the comment section. So thank you very much for watching. In our next video, we'll now talk about the power in an AC circuit. Maybe I should just solve one question on that, then we are good to go. So let us not waste our time. Okay, let me just go straight and have just one video for this, and then I am done with everything concerning or let that be in the next video anyway. So bye bye.